In this video, we're going to talk about acceleration. Acceleration is the change in velocity over time. The change in velocity, we could write it this way: delta V. It's the same as final velocity minus the initial velocity. Okay, and it's over time. So over time. So if the velocity is changing, we have acceleration. And we can talk about the average acceleration or the instantaneous acceleration. So the average acceleration, we can write it like this: A for acceleration, AV for average. And because it's the change in velocity over time, acceleration is a vector, just like velocity. So if we had average acceleration, so let's say we had a graph of velocity over time, and we get the velocity changing over time, the average acceleration would be the total change in velocity, divided by the time. The instantaneous acceleration would be the acceleration just at one point. So let's say this is 5 seconds. We want to know the acceleration at 5 seconds exactly. That's the instantaneous acceleration. We go up to our line, we use a ruler, and we draw a tangent line, and we find the slope of this line. So if you look at the previous video on instantaneous velocity, it's exactly the same process to get instantaneous acceleration. Okay, these examples in this video are all average acceleration. Can we have negative acceleration? Well, if this is our formula up here for acceleration, can this be negative? Yes, it can. If the initial velocity is higher than the final velocity, then yes, this will be negative. So yes, if the initial velocity is higher than the final velocity, then we're going to get a negative value up here, which will give us negative acceleration. And if you just think about this for a second, if the initial velocity, that's the starting velocity, is greater than the final velocity, that means the object is slowing down. So slowing down is negative acceleration. In everyday English, we use the word deceleration, but we're going to call it negative acceleration, because it highlights the negative part, which is the direction associated with the vector. Okay, let's do an example. A Ferrari F430. If you have about $200,000 US, you can buy one of these. They go from 100 kilometers per hour to 4 seconds. They go from rest, so 0 kilometers per hour, to 100 kilometers per hour in 4 seconds. Calculate the average acceleration. Okay, so the initial velocity is rest, so that's 0 meters per second. Final velocity is, this is kilometers per hour, 0 kilometers per hour. And final velocity is 100 kilometers per hour. And this is velocity. It does have a direction, so let's just put a positive sign in here so that we remember that this has a direction. And it takes 4 seconds to go from 0 to 100. Okay, well, the time here is in seconds, and the unit for time in our velocity here is hours. So it would be easier if we had the same unit for time. So why don't we change 100 kilometers per hour? Let's change this into meters per second. Okay, now there's another video on unit conversions if you don't know how to do this. 100 kilometers in 1 hour, and 1 hour is 3,600 seconds. And there's 1,000 meters in a kilometer. And this will allow kilometers to cancel, hours cancels, the only units left are meters and seconds. Okay, this is 27.8 meters per second, and this is positive. Okay, so this is our final velocity. So now we can use the equation. Our average acceleration is our final velocity, that's positive 27.8 meters per second, minus our initial velocity, which is 0 meters per second, over our time, 4 seconds. Okay, please pause the video and try it with your calculator. And you should get about 6.95 seconds, or sorry, 6.95. Now let's think about the units here. Up top, the unit is meters per second, and down below is seconds. So let's just come over here for a second and see if we can make sense of this. We've got meters per second on top, divided by seconds. So it's meters per second. Well, that sounds kind of weird. Well, remember when we divide by a number, it's the same as multiplying by the reciprocal. That means meters over seconds multiplied by 1 over seconds. This is the same as this. But when we write it this way, we can see that this is the same as meters over second squared. Seconds times seconds. So the unit for our acceleration is meters per second squared. And this is positive. Okay, let's do another example here. A person is running 4 meters per second north. Then they turn around and run 3 meters per second south. It takes them 3 seconds to turn around. What is their average acceleration? Okay, so final velocity is 3 meters per second south. Let's use the positive sign for north and the negative sign for south. Just makes it a little bit easier in our calculation, and we can change it back to north and south after. So 4 meters per second, 3 meters per second south, so let's say negative 3 meters per second, and our initial velocity is 4 meters per second north, so we'll say that's positive 4 meters per second. And it takes them 3 seconds to turn around, so that's our time. So our formula for average acceleration is final velocity minus initial velocity divided by the time. Negative 7 meters per second divided by 3 seconds. It's the same as negative 2.3 meters per second squared. And now we can go ahead and change this negative back into south. So we'll say 2.3 meters per second squared south. Okay, now we'll do one more example. This is an example of cyclists slowing down. So their final velocity is 5 meters per second. Their initial velocity is 15 meters per second. Okay, now let's use, they're going in the same direction, so let's just use positive signs. This would be easy. And their initial velocity was positive 15 meters per second, and the time for this change was 5 seconds. Okay, so put this into our formula here. Our final velocity minus our initial velocity over time. So you can see this becomes negative 10 meters per second over 5 seconds. And so you can see how this is a good example of negative velocity. Negative 2 meters per second squared.